710, Electron Configuration Part 2. Now, I just wrote Part 2, and I didn't put the work to do yet because this might take several videos. This is a lot of information, and I might just do it in parts just because it's a lot of stuff, and I'm kind of doing this I'm actually doing, sometimes I do these videos in between the classes too. But basically, here's the bottom line. The worksheets that are in this 7.9 and 7.10, what you'll do is you'll look back. First, you'll do all of 7.9. You're going to do all the electron configurations of everything, okay? There's like 8 elements there. I'm going to tell you how to do the other 2 in a moment. Then, when you take that, when you take your elements, like say you did the electron configuration, you know, the whole thing for, I think one of them is, I don't have it in front of me. Oh, well. Oh, no, I don't have them in front of me. Carbon is one of them, I think. Maybe manganese is in there or something like that. Well, anyway, what you'll do, you'll look at it and you're going to analyze the worksheet. So you'll take your worksheet, like say, look at letter A, and then in this part, you're going to look at worksheet and tell me about element A and go through it. And then here, A, B, C, D, E, F, G, and, you know, all of these A, B, C, D, E, F, G, H, A, B, C, you know, everything in this part, these first sections all refer to your old worksheets. Then this is going to be some different stuff that doesn't. So it'll probably take a couple of times of work. We won't go over all of this in this lesson now. We'll do a lot of it, but okay. So here we go. Let me go back to where I was yesterday and let me kind of review. I've been leaving this on the board because before I erase it, I wanted to kind of get it back to you. Oh, here it is. I was trying to find the eraser. Okay. So some things you need to know about Hakotel. First of all, you need to know how to draw this. To draw this at 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. This tells you the order that the rooms in Hakotel fill up in. Or another way to look at it, if I come over here, you know, I could take this pattern and just draw my whole little, like a seating chart, or what do you call it? Or actually, you know when, back when you could go to movies and stuff, and you went to a movie, and you come in, and now they pretty much all have the stadium seating. You're going, okay, where do you want to sit? And they show you, they turn it around, they show you this chart. You want to sit in, you know, 7E, 7R, whatever it is. You pick 17F. You pick where it is, you know, on the seats. Well, think of it this way. This tells you where the little rooms are. Well, instead of seats, they're rooms, but every room can hold 2. So 1S, 2S, 2P, then comes 3S. 1S first, then comes 2S. 2P is next. And remember, there must be 3 rooms. Anytime you come to a P, there must be 3. Oh, I got it over here. Anytime you come to a P, there has to be 3 rooms in the P level. All right, so 2P. Okay, all right, then comes 3S, just 1 room. Then comes 3P, because there's 3 rooms again. Then comes 4S, 1 room. Then comes 3D. Anytime you come to D, there's 5 of them. Okay? Then, if you continued on, there'd be 4P. There'd be 3 of them. Okay? 4P, 4P, 4P. Then would come 5S. Then would come 4D, 5 of those. Then 5P, 3 of those. Then 6S. So you kind of need to memorize that little bit. You're really not likely to ever have to draw anything more than that, even in my class or on an AP exam. But you know, if I were to ask you, even in general, if I were to ask you something about the higher electrons, I could take some element and just say, well, just tell me from 4s, how does it look from 4s up to 5p? And you could just draw 4s, 3d, 4p. You know, you could do those 5 or 6 and go from that part of the element up. But you know what? Right now, that might sound like a hard thing to do. So don't even think about that right now, okay? Because I'm going to show you some stuff. After you've gone through a few more video lesson sections, it's going to become a lot easier to you. This whole thing. In fact, this, you're not even going to really need it that much. Maybe I'm going to get into that today a little bit. I might just do that and talk about the chart. But you'll see. It'll come into play. You're not going to need it as much. But the reason I tell you that is because this is something that you will never forget. Like 2 years or 3 years from now, you're in college taking chemistry, and you're like, oh yeah, electron configuration. Oh, wait a minute, what goes first? Is it what is it? Well, if you know 1s, 2s, 2p, 3s, 3p, 3d, the 4th floor, 4s, 4p, 4d, 4f. Then just go spdf all the way to 7. Then do that. This will tell you the order they fill up in. So you will probably not ever forget this. And then the other thing to remember is when an s level is full, it has 2 electrons. So in other words, s goes all the way up to 2. It's full. The p level, when it's full, it has 1, 2, 3, 4, 5, 6. It goes all the way up to p6. So it maxes out at p6. Any of these, 3p6, 2p6, 5p6, whatever. D's will max out at 10, and that because there's 5 rooms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So D10, then once you get to D10, now you know it's time to move to the next level. Okay? And then F's max out, there's 7 of them at 14, and you're almost never going to see any F's anywhere really at all. Oh, I can make a mess out of that. F14. So S2, P6, D10, F14. Okay. Now that I've shown you that, I'm not going to erase it all yet. I want to continue with ions first of all. Okay, so I told you that when you're making the electron configuration for an ion, you know, if it's negative, you just gain electrons. Like, for example, if I, let's see, let me pick one. I already showed you oxygen. I showed you that one already. Like I said, oxygen, atomic number is 8. So if oxygen has 8 electrons, Z equals 8 for oxygen. So 8 electrons. So just go 1, 2, 3, 4, 5, 6, 7, 8. Okay, which means 1s2, 2s2, 2p, 1, 2, 3, 4, 2p4. Now see, you can also do this without this chart here. You don't have to have that chart if you're in your mind, if you get kind of better at it. Because you know, the first room is 1s. Because remember, 2 plus 2, what a mess I wrote that. 1s2, 2s2, 2p4. 4 plus 2 plus 2 is 8. 4, 5, 6, 7, 8. Oxygen is number 8 on the chart. Okay, forget the charges. That was something else I had there. So, I can just, another way to do oxygen is say, well, okay, here's oxygen. 1s. So first I've got 8 electrons. 1s, 2 of them can go there. It maxes out at 2. Then comes 2s. It will max out at 2. 1, 2, 3, 4. I have 4 more electrons. The next room is 2p. Can I fit 4 in that? Yes, they can all fit there. You can fit up to 6 there. So 1s2, 2s2, 2p4. So you don't really have to have this. In fact, you'll see in a minute, well, a little bit later on, I'm going to show you some more shortcut. But here's another thing. If I want to do oxide, O makes a charge of -2 when it combines, when it reacts. O -2. So, -2 just means it gained 2 electrons. It still has atomic number 8, but it has 10 electrons. Remember, oxygen, -2, because it has a, well, it's always going to be +8 nucleus for oxygen, but outside is -10. The electrons are, there's 10 electrons. So, 1, 2, 3, 4, and that means I've got 1s2, 2s2, 2p. That's going to be a 6, 7, 8, 9, 10. It gains 2. So oxide will gain 2 more electrons. They go right here. This chalk is getting small, and I've got to go get my other chalk. I think it's outside. Can't run to my car now. But okay. All right, so here's what we'll do. Now, what happens when you have a positive ion? All right, let me try and get this stuff out of there for a minute. Well, actually, I can do, well, you know what, now that I did that, I think I'm going to keep it there, but oh well. Let's do this one. What element is 1s2, 2s2, 2p6, 3s1? What would that be? 3s1. 1s2, 2s2, 2p6, 3s1. Well, one way to do that, we're going to show you an easier way even later. 6, 7, 8, 9, 10, 11 electrons. 6, 7, 8, 9, 10, 11 electrons. That will be sodium. So you look on your chart, you say, oh yeah, sodium has 11 electrons. As I said, I'll show you a better way. Okay, so that is your sodium metal, is 1s2, 2s2, 2p6, 3s1. Now, sodium makes a common charge of +1, Na+1. That means you lose an electron. And so here's the rule. Listen carefully. Remember, in the Hog Hotel, this is the order you fill up in. And you pretty much start at the low levels and you go up to the higher. Now, you skip around a little bit, I told you, because of the negative repulsion that builds up. it starts to kind of, a few go up here into the 4s, then they come back down to 3D and so forth. And that happens a lot in here. In fact, look at, I think it's 4F. Yeah, look at what happens. You fill up, after you fill up 4D, then you fill up 5P, then you fill up 6S. After 6S, then you go back to 4P. 4F, I'm sorry. 6S, 4F. So it's like, remember the hog, smelly. Oh, it smells so bad. So, I'm going to be repelled up to the level 6. But then you come back down and you finish filling up 4 and 5 again. 4F and 5D, then back to 6. So there's a lot of weird stuff like that. But anyway, it pretty much goes in order, maybe jumping around a little bit as you fill up. Well, here's the deal, though. When you lose an electron, ionizing, sodium loses, you always lose it from the highest floor of the hotel. Always. Okay, always from the highest floor. So what that means is, okay, it won't be a big deal for sodium. Sodium, the highest electron is in the hotel, the highest hotel room is 3s1. So it's going to lose that one right there. That's the one electron it will lose. So sodium ion is 1s2, 2s2, 2p6. Now, I guess I can throw in one other word here. You're going to see it later on, but I might as well tell you. Sodium had 11 electrons. Sodium ion only has 10. It loses one. When it loses an electron, look, neon also has 10 electrons. When sodium loses an electron, it doesn't change into neon because it still has 11 protons. Now, you might remember the identity of an element is based on the nucleus, the protons. If you have 11 protons, you'll always be sodium, no matter what. You can change whatever things about you, positive, negative, whatever, electrons, but you're positive, you're still. Okay, so, but it has the same electron configuration as neon. And I'm going to bring this up. This is in another section, but I'm jumping ahead. Neon has 10 electrons, 1s2, 2s2, 2p6, 6, 7, 8, 9, 10. So we call those isoelectronic. And you're going to see it later, but I just thought I would tell you now. Isoelectronic means they have the same electron configuration. So two things can have the same electron configuration, but they're different elements. But there can be something similar to them about reactivity. In fact, it's something that I would throw in there now. I guess I'll tell you already. You know, noble gases do not react, like neon. Well, sodium, in this form, it's very reactive. But once it loses that electron, when it has we call this a full shell, meaning everything, when you lose that electron, everything from the bottom floor all the way up is completely full. It becomes more stable and like unreactive. So sodium plus 1 is no longer reactive. Okay. Well, anyway, a lot of elements, when they become isoelectronic with a noble gas, they become non-reactive. And we'll show you that. Well, I'll say stable because they could possibly. Now, the harder one would be, I think I told you, titanium. Let's do titanium plus 2. And yesterday I did titanium, or yesterday lesson, because it was yesterday for me, but 22 electrons in titanium. Let me see, 22 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So for titanium, the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, oh boy, 3d2. Wow, I'm going to run into my little chart here. Soon this chart's going to go away. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. This is the electron configuration of titanium. Now, if I lose 2 electrons, let's just say I want to turn this into titanium plus 2. I can call part 2. The video cut off. That hadn't happened in a long time, so I forgot about that fun thing. So, all right, whatever. Memory got full and it just stops, but oh well. But it didn't. It looks like it saved the video. Here I am. Sorry. Titanium. Okay, we said 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Now, if I want to make titanium plus 2, in fact, I meant to mention this. If you see on a worksheet or a paper or on a quiz or on an AP exam, draw the electron configuration, write out the electron configuration for titanium plus 2. If they ask you, write it for titanium plus 2. First, even though they didn't tell you, you should just do titanium. First do titanium, then make the adjustment. Same way, write the electron configuration for O negative 2, like I did a moment ago. Or first just do O, and then say, oh, I've got to add 2 electrons. So we do titanium first, O positive 2, you got to take away 2 electrons. Now the rule, as I said, you take them away from the highest floor of the hotel. And so the highest floor of the hotel, 4s or 3d, it's actually 4s. So even though we write the configuration this way, 4s is really higher up physically or farther from the nucleus in general than 3d is. They're really close. It's a weird thing we'll show you later, but this would be a higher floor. So 4s is higher than 3d. Okay, so you lose the electrons out of there. Now, if you made titanium plus 1, you just have 1 electron out. And there are some elements that are that way. They're pretty much in this section in the chart. Pretty much any element in here that's a positive 1, like gold does that, copper does that. If you see anything that's positive 1 in this area, well, then it would lose like 1 electron. Titanium loses 1 electron, it becomes titanium plus 1. And it would be 4s1, 3d2. Kind of strange. But then when you lose another electron, there's something about, I didn't tell you about the, I don't want to confuse you. Well, you know what, I'll get to that. I'll wait and tell you, there are some little exceptions to electron configuration. There are some, okay, I better say this right now. If you do the electron configuration, if you sit down and say, hey, I'm bored today, I think I'll write down the electron configuration for every element on the periodic table. And if you use this and you go through all of them, you're going to get most of them correct. Oh, what is that? Good teaching. Well, the thing is, there are many exceptions, and we don't really have to know the exceptions. They're not going to ask that. There are a few exceptions that you should know about, and I'm going to tell you about those later on. But don't worry about it right now. So if you see somewhere else, if I ask you to write anything on my quizzes or homework or test or whatever, just do it the way I've taught you to do it, all right? Now, it might contradict something that you see somewhere else, but I'm just going to ask you to follow the pattern. We're pretty much going to do the basic elements. But there are a couple of advanced ones that AP would need to know how to do, where they do some weird stuff. They shift around the electrons. And I'm going to tell you all a little bit about that later. But okay, all right, so anyway, back to this. So what is titanium plus 2? You take away 2 electrons from the 4s, and it becomes, really, so 1s2, 2s2, 2p6, 3s2, 3p6. So the 4s, you could just leave off 4s, or you could put 4s0 if you want to. I guess I would put, I might put 4s. I don't know what I would do. If it were the AP exam, maybe I would put 4s0. Maybe I would. Okay? And then 3d2. But you don't have to put 4s at all there. Just because at least you're showing them, hey, I know it came out of the 4s0. That one was empty. Those are the ones that left. All right. So now you're able to do all of A, B, C, D, E, F, G, H on that first worksheet. So this is 2 extra ones. But then there's some more stuff I want to show you. And I think, okay, regrouped. All right, short form configuration. I think I've got enough time just to show you short form. Let me do that. And then I'm going to, we'll see. I got a little bit more time here. Okay, so here we go. All right, so we got the Hog Hotel, helicopter thing, SPDF, and all that. We talked about how it works. Okay, let me go over here. Short form configuration, and yeah, that's the first thing I better do. I better talk about short form and the periodic table. Okay, here we go. Well, here's the neat thing. The periodic table is actually designed, the shape of the periodic table is designed based on electron configuration. You'll be like, why didn't you tell that in the beginning? Well, so I've talked, whatever, almost like over an hour on all these videos you've seen, and I didn't want to tell you this until now. because I want you to understand the whole structure to make sense, kind of. Okay, here we go. So first, on the periodic table, I'm going to kind of draw it like this for a moment. Well, I won't do a very good job of it, but oh well. I'll just kind of come down there like this. Okay, on the periodic chart, oh boy, that's too big there or whatever. Well, I really messed up there, but oh well. These are called the S blocks. Oh, you know what? Well, I'm about to say I could draw it. I could draw it on here with a marker. I don't know if I have another colored marker though. Well, these first two are called the S blocks. S blocks. S. All right, let me talk about what that means for a minute. Everywhere on the chart, these are the S, and on this side are called the P blocks. These are the D blocks, and these are the F blocks down below. Now, what in the world does that mean? Well, a block location for an element tells you the highest room in the Hog Hotel that has an electron in it. It always tells you that. And what's really cool is the chart is made to show you it's based on this. Now there are some exceptions even on this. I'm going to show you there's some exceptions, but I'll pretty much do it this way. This is period 1. Let me try to get to the side. That's period 1, 2, period 3, period 4, period 5, period 6, period 7. So the first floor, Hog Hotel, the second floor, the third, fourth, fifth, sixth, seventh. So it's kind of like the upside down. That's probably why they do it this way. And some books will show this whole chart upside down. But oh well. But there it is. All right, so first floor. Okay, watch how this works. And I'm going to just kind of say it. You might have to run back if you don't quite get it. The first electrons, let's say that all your chart's empty of electrons. You start filling them in. The first electron goes right there into hydrogen. 1s1. Everything in this row counts as s1. Everything in that row is s1. Think about that for a minute, and I'll show you. Hydrogen is 1s1. That's easy. Do we have any space down here? I guess I do. Hydrogen is 1s1. Well, let's go to the next. How about lithium? Well, lithium would be 2s1. 2s1. Lithium, right? These are all s1s. 2s1, 3s1, 4s1, 5s1. Okay, well, what does it mean? If sodium is 3s1, why do we know that? The block location, 3s1. What that means is that is the highest hotel room occupied for sodium. The highest hotel room, in Hog Hotel is 3s1. So it tells me everything up to 3s1 is completely full. So sodium, its electron configuration ends at 3s1. That means it must be 1s. Okay, what's the max? 1s2 maxed out. Then comes 2s2 maxed out. Then comes 2p6 maxed out. Then comes 3s1. So 1s2, 2s2, 2p6. Look at that. So you can memorize it now easier when you know the block location. All right. So these are all that way. But how about cesium would be 6s1. So I don't really want to go through this, but if that's 6s1 for cesium, then that means cesium would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s1. So as long as you know how to max out everything all the way, that's another way you can do the electron configuration. All right, but there's even a better way. Another way I'll show you in a second. All right, so if these are all S1, guess what these are? These are all going to be S2. So, S2. So, there is no 1s2. Well, no, that's not true. There is 1s2. It's over there. It's helium. It's not in this location, but that is 1s2. Helium. Sorry about that. It's not put there. But we go down below it. Beryllium is 2s2. Magnesium goes all the way up to 3s2. Okay? Calcium, 4s2. Okay. Now let me show you how the chart kind of works out. What happens, now I want to show you that the chart is designed according to the blocks, the S, P, D, and F. On the chart, first comes 1s1, 1s2. Okay, let's kind of forget about that one. What comes after the 1s? Then you start the 2s1, 2s2, Okay, so 2s1, 2s2 comes here. 1s is full. Hydrogen, helium. 2s1, 2s2. That takes you to beryllium. What is the very next element going to be after beryllium? Boron. What is that going to be? Well, according to the line diagram, after 2s2 comes 2p1. And so guess what? Boron will be 2p1. Guess what carbon is going to be? 2p2, 2p3, 2p4, 2p5, 2p6. It still works. Everything fits on the periodic table. Isn't that great? So, these are all P1, P2, my ink is going out, P3, P4, P5, P6. I tried to write it the best I could with this thing running out of ink. P1, P2, P3, P4, P5, P6. Okay, so boron is 2, second period, P1. So that means everything up to 2P1 is full. If I want to write down boron, I can just say, well, boron is 1s2, 2s2, 2p1. Boron is 2p1. So everything before 2p1 we got was full. 1s2, 2s2, 2p1. All right. Let me, I think you kind of get the hang of this, but let me do another one. Let's go all the way and do nitrogen. All right, nitrogen is going to be, or I think I got a better idea. Let's do phosphorus. So phosphorus is 3, and then this is a S, 3s1, 3s2, 3p1, 3p2, 3p3, 3p3. Phosphorus goes to 3p3. So everything up to 3p3 is full for phosphorus. So 1s2, 2s2, 2p6, 3s2, 1s2, 2s2, 2p6, 3s2, 3p3, like that. Okay, so everything across tells you phosphorus. So the chart actually turns out that it can show you don't need this because you have the chart now. But see, what I tell everybody is, years from now, you might forget about the chart. You might forget where that's the S, the P, the D. You might forget that. But you probably will not ever forget how easy it is to draw this. 1 SP, SPDF. So let this kind of be the guideline, the law. If you forget things, you can always write that down, a quiz or something, write it down on your paper and look at it there. And then know that this is based off of that. So in this chapter, we have quizzes, tests, and all that. The next few weeks, you're probably going to memorize it. You're not going to need this that much, okay? But say that like at the end of the year, the exam comes, or AP, before the AP exam. You got, it's been 2 months. I got to review this stuff. Well, you probably will think, okay, well, I know this, and how does it work? Oh, it looks like this, okay? First comes, let me see if I can stand here and do them at the same time as I point to it. First comes 1S, 1 and 2, okay? Then comes 2S, 2S1, 2S2. Then comes 2P, 1, 2, 3, 4, 5, 6. Then comes 3S1, 3S2. What's after 3S2? 3P, 1, 2, 3, 3P4, 3P5, 3P6. Then comes 4S1, 4S2. Now here's a neat thing, I didn't tell you this yet. After 4S1, 4S2, what does it tell you over here? What happens next? After 4S1 and 4S2, then you go to 3D. And that's why these are the D blocks. So 4S1, 4S2, that will be 3D1. I don't know if I can write that all down. Just look around with this pen. 3D1, D. Well, here it is. D1, D2. It's going to run out. If I hold it down, it'll work. D3, D4, D5, D6, D7, D8, D9, D10. D1, D2, D3, 4, 5, 6, 7, 8, 9, 10. There are exactly 10 spaces right there for the D electrons. Okay. So if I take for example, actually we did it earlier, titanium. Titanium's block. Okay, now I didn't tell you this. So there's one more story about the Hog Hotel. So the Hog Hotel on a mountain, mountains were formed long ago and from volcanoes and all this. So there was an earthquake, boom, and all of the D floor, the D section dropped down one floor. Okay, so that's a little story to tell you. So even though this is 3S, 3S1, 3S2, and 3Ps, well, this is actually 3D1. After 4s1, 4s2, then comes 3d1. But guess what? After 5s comes 4d, 6s, 5d, 7s, 6d. So you're always going to be after the s's, you're always going to go like 5s to 4d, 4s to 3d. And I'll talk about the F in a minute. That's a little crazy. Okay, so titanium, its block location is 3d2. 3d2. So everything up to 3d2 is full. So for titanium, 1s is all full. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. All right? Okay. Now we're ready to get to those crazy. And so if I were to say what is gold, you'd say, well, gold is D9. Well, that's 1, 2, 3, 4, 5, 6. All right, this is period 6. I erased it. 6. So that means that this would be the 5D9. 5D9. But now something else weird happens after 6, and I got to get to that. Okay, after 6S, look at what happens. Always go back to this when you forget about how does this work. Look at this. What happens after 6S? You go to 4F1. What? 6S to 4F? How does that work on the chart? Okay. Well, if you look on the chart, and they're kind of getting rubbed off here. After 6S, 1, 2, 3, 4, 5, 6, barium. 6S2. Barium is number 56. So 55, I can't really read it that good. 56. But then on your chart, if you look after 56, it goes all the way. You see 57 here, but then it jumps to 72. So 57 is called lanthanum. 56, 57. But then where's 58? Up, it's down there. 58, 59, 60. Okay, so what happens is this. All right, watch. This is 6S1, 6S2. That count. Count that as 4F1. Now, if I were just to ask you, now this is only for an AP thing, but if I were to ask you what is lanthanum, lanthanum is 5D1, okay? And actinium down here is going to be 6D1. If I ask you those individual. All right, but what happens is once after lanthanum, it's really weird. After 6S and 5D1, then we go down here and they start to fill up the Fs. Now, when we go down to this element, to 59, for whatever reason, it pulls that electron with it. It's very strange. So you can just ignore that. Count that as F1. That's what I'm trying to tell you. If I ask you for lanthanum or actinium, yeah, that is D1. That's true. But I'm not going to really probably do that. They could ask for AP. They could ask you to know that. But if I ask you anything in the F column, count that as F1. So in other words, 6S1, 6S2. And remember, it's based on this. After 6S comes 4F. So count this as 4F1, 4F2, 4F3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 4F14, you'll count that. Then after 4F14, then you'll count 5D1. It will count that as 5D1. No, it's more like a 14, but count it as 5D1, and that's number 71. Then 72, 5D2, and now you're back on track. 5D2, D3, D4. So you never have to worry about that weird counting unless you're doing an element that stops in the F blocks. So if I were to say to you, okay, what is SM? It's called samarium. What is samarium? Then what you would do is you'd say, oh, it ends in the F. So 6S1, 6S2, count that as 4F1, 4F2, 4F3, 4, 5, 4F6. Count it that way. And you'll get most of them right. Not all, but most of them right. So that tells you to count that as F2. I can't even write that. F2, F3. The ink is really going out. F4, F2, 3, 4, 5, 6, and so forth, all along there. All right, okay, this is part 2, part 3. You know, I might try to link these videos together. Good gracious. I had one that cut off. One video cut off. Then the next video, I was doing it, and I realized, well, you didn't see the end of it, but I didn't tell you how to do part of it. There is an assignment for this, but I did not explain how to do it. The assignment won't be much. But I gotta show you one more thing. All right, it's called short form electron configuration. All right, first, In the last video, here's what happened. I was showing you the blocks. F2, 3, 4, 5. Oh boy. This pen is really out. 6, F7. You know what? You're not even going to be able to read this. Well, you might kind of. 11, 12, 13, F14, then D1. Okay. Well, anyway, this is what it looks like where all the things were. The S blocks, S1, S2, D1. Remember this, 1S2, 1S1, 1S2, 2S1, 2S2, 2S, 2P, 1, 2, 3, 4, 5, 6, 2P6, 3S1, 3S2, then 3P, 1, 2, 3, 4, 5, 6, then 4. See, it's really hard to keep my pen working here. I think I've got another pen somewhere. Gotta look for it. Oh boy. Okay. Well, anyway, 4S1, 4S2. Then remember we dropped down the earthquake. 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3D10, 4P1 through 6, 5S1, 5S2, 4D1 through 10 to there, 5P1, 2, 3, 4, 5, 6, 6S1, 6S2. Now, on a chart where the numbers have not been messed up, it makes a lot more sense because you're like, well, okay, if this is 55, 56, 57, then why does it jump to 72? So that ought to be a little key warning, red flag. S1, 6S2, then 4F. It goes down 2 numbers now. The earthquake dropped the F's 2 levels. 4F1, 4F2. I try to write it down there. F2, F3, F4, F5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That'd be 4F14 as you're counting. Then that would be 5D1, which is there again, back to there again. Then we continue. Because that was number, what does that say? Oh boy, 71. 71, 5D1. Then 72, 5D2, and now you're back on track again. So the main thing about that, and you're not going to hear F's very much at all. Really, probably not even in AP. Probably not even on an AP exam. But I'll just tell you, if I were to say to you, what element is 4F3. Okay, 4 F's are down here, but count that as 4F1, then 4F2, 4F3, PR, called praseodymium. If I were to say which one is 5F10, okay, then count, here's 7S, then comes 5F1. Count that as 5F1. So start counting that as 5F1, and that is 4F1, when you're going to end in the F column. Now, if you're going to end in the D column, just start that as D1. So it's kind of weird. So you're not going to see it much, but so if I said, where is, here's 6, where's 5D3? 5D1, 2, 5D3 is right there, and it works. But if I were to say, where is 5F3, okay, I guess I didn't do the other one, but 5F10 or whatever, 5F3, well, 5Fs, this is 4F, that's 5F1, 2, 3. So PA is 5F3, 4, 5, 6, 7, 8, 9, 10. 5F10 will be CF, Californium. Okay, well, you're not going to see the F's very much. Okay, well, here's the last thing. I can't believe this is actually helps you a lot, shortcut, when you kind of know this as well. But there's something called a short form configuration, or noble gas electron configuration. So noble gas or short form electron configuration. Now, there is some usefulness to this. For a long time, like in AP, they didn't even talk about this on the AP exam, but I did see it on the AP exam some recently. And here's what this does. Now, you'll like this, but you can only do it, you have to use a noble gas in the short form, okay? It's somewhere in it. Let me give an example. All right, so let's just say that I'll pick nitrogen right here. What is the short form for nitrogen? Okay, here's what I'm going to do. For nitrogen, First, let's write the long form until we learn about the short form. The long form, we know it ends at period 2p3. 2p3. So nitrogen goes all the way up to 2p3. It goes up to 2p3. So that means 1s2, 2s2, 2p3. Now, what you do is you look at nitrogen and you find what is the noble gas that comes before nitrogen. Before, I said before, not after. That would be neon after, but before it, you go backwards, and it's helium. Helium comes before neon. Before nitrogen and neon. Okay, so what is helium's electron configuration? Now look at helium. Helium is 1s2, 1s1, 1s2. It stands for the 1s2 block. So what that means is, since helium equals 1s2, then in nitrogen you can just say, well, see that right there? That could be replaced by helium. So instead of writing 1s2, 2s2, 2p3, for nitrogen you write in brackets, it has to be in brackets, helium, 2s2, 2p3. Now, you might say for a minute, why is that a shortcut? Why is it better to do that? Well, right now, and really it's not a shortcut for nitrogen, but it does tell us something, and I'm going to get to that in the next lesson. But this, for now, it does tell us the electrons that are in the outer shell, which are very important. All of these are the inner or the core electrons, and a kernel, they call it kernel, like a popcorn kernel, the kernel or core electrons, and these are your outer. Okay, so why, that's not a short form. Well, let's pick another element, and we'll see how it is a short form. Let's pick sulfur. Sulfur goes all the way to P4 of what? 3P4. So sulfur goes all the way to 3P4. So now that means, 1s2, 2s2, 2p6. Well, I would run out of space right when I started that. 1s2, 2s2, 2p6, 3s2, 3p4 is sulfur. Now, what noble gas comes before sulfur? It's neon. And neon stands for what block location? 2p6. So what it tells us is everything from 1s2 to 2p6, that is neon. I don't have to write that. Sulfur is just like neon. Another way to look at it is this way. Sulfur's configuration is just like neon, but then we have to add 3s2 and 3p4 onto that. Aha! Now you can see how that kind of helps. All right, it can really help if you're doing something like potassium. Potassium goes all the way to 4s1. Okay, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 for potassium. But the short form of potassium, just look at this. What is the noble gas that comes before potassium? We go back to argon. Argon. So it is just like argon. Argon stands for everything all the way up to 3p6. So in other words, I don't have to write anything but argon. Argon stands for 1s2, 2s2, 2p6, 3s2, 3p6. All of that, the 3p6, and then you add on to argon 4s1. And then you get, argon, you add 4s1, you get potassium. So that is what I mean by the short form electron configuration. Now, let me just show you at least one of the crazy F ones. Like I told you, most of these you'll get right, and I'm not going to really be asking you Fs and stuff like that. Or I can do a D one. Let's do a D one, titanium. Or we'll do vanadium. Well, which one? I don't know. How about none of them? How about zirconium, Zr? All right, remember, what is zirconium? Where does it end? To get the short form of zirconium, let's go backwards and see what noble gas came before it, and it is krypton. So zirconium is just like Kr, krypton. In other words, krypton stands for everything from 1s1 all the way to 4p6. So just write krypton and then add on to krypton 5s2 and then 4d2. Krypton, 5s2. Take a krypton noble gas and add on to it 5s2, 4d2. 5s2, 4d2, and you'll get to zirconium. So, I'll do one of the Fs. In fact, on the worksheet, I think I corrected these worksheets because there was an error one time on one of these. No, I fixed them, I think. Oh, well. But if you wanted to end, like I said before, like I think I did this one already, but say you wanted to end at 5F4. If you want to end at 5F4, then that would be 7S1, 7S2, 5F1, 2, 3, 4. That would be uranium. So uranium would be just like radon. Rn, radon. That's a radioactive gas, actually. Radon, then you add to radon 7S2. Oh, I'm sorry. Uranium is radon. Then you add to it, I'm going to run out of space, and this is the last one, 7S2, and then 5F, 1, 2, 3, 4. 7S2, 5F, 1, 2, 3, 4, 5F4. Okay, so now, I'm sorry, normally I don't take it at the end. I'll try to type it on the paper. But what you should do for your work, you should have all of the first page and the second page finished from yesterday. So in other words, A, B, C, D, E, F, G, H. All the electron configurations for the ions, everything should be done. Okay. Then what you do is then just go and do part 4 and part 5 on this worksheet. Only on the bottom left. So it's not very much work today. There's a lot of information and a little bit of work. But now part 4 is going to refer back to the worksheet. Like, for example, I can't remember which one is scandium. Is it C? Well, I remember one of them was scandium, and I should do that one for you. But like it says, write the symbol of the element A through H, and then write the short form. So for scandium, for example, for that one, whichever one is scandium, ABC, I'll just tell you, you'd write down the symbol SC in the first box. Then in the next box, you'll write the short form. And for scandium, it's really simple. It's going to be argon, 4s2, 3d1. Argon, 4s2, 3d1. So that's one of your answers. Wow, that chalk is really bad. Okay, well anyway, so a long, crazy lesson. I'm going to either try to patch it together. I know it's a lot of parts. Okay, so get that done, and then next lesson we'll really go through a lot of this stuff, and it'll probably be easier. I'll see you. But hopefully this is going to make everything a whole lot easier now. I'll see you.